Okay, I think we will start now. I will check my cameras there. There you can see coffee, my coffee cup there. Very important word when you are living in Finland is kahvi. This is coffee. I think Finns are drinking most coffee in the world, or at least in some statistics it was shown that. But I can understand because we all the time drink coffee. That was because I have this coffee cup here. And hyvää iltapäivää, good afternoon to all of you. I'm sorry this camera is there, and or there it is. Probably I'm looking to the wrong camera all the time. This studio is made somehow strange that it is sometimes hard to understand what camera is filming me. But today we will go to the oblique triangles. Unfortunately, I have been ill during this week, and right now I think I'm feeling quite well, but my voice is not well enough. But I'm lucky to have a weekend after this lesson, so I hope I will be better in the Monday when we probably meet next time. So this is oblique triangle, and this is in Finnish vinokulmainen kolmio. It means this vino. I checked from the Google Translator, and it gave me translation that this vino is in English oblique. For me, this oblique is quite strange word, but in Finnish, this vino means that, for example, if you have in your house you have a wall, and now it is correct, it is standing straight upwards. But if it's vino, it is like this. This is called vino in Finnish. Vino seinä, oblique wall that does not stand straight upwards. And kulma means angle, and kolmio means triangle. And I will take an example of some problem. Let's take example 1. Example in Finnish it is. Let's take another color. Example it is esimerkki in Finnish. Esimerkki. Actually, I simply don't understand why does this mean same as example. I think probably this esi word. In Finland we have this esi word. For example, if you are having a grandfather and his father is your great grandfather, and you may have great grandfathers, ancestors, you may call them esi-isä, or this great grandfather. It is esi-isä. Isä is father. But I don't understand the logic in this word. But it means the same. Probably this esi comes from this x in this English word. I'm not sure. But let's take a example of oblique triangle or vinokulmainen kolmio. Actually, these formulas we are using in this example or these examples today, we are using formulas which are capable to use in every triangle, in any triangle you may find. Also, you may use them to right angle triangles. But these formulas for right angle triangles are such easy that mostly it is easier to use those. For example, this Pythagorean theorem or these sine, cosine or tangent definitions. But these formulas do go in every triangle you may find. And now the logic in those any triangles or oblique triangles is that you have the same names for the sides, but not necessarily anymore so that the C is not every time the longest one, as it was in right angle triangle. In those triangles, they every time the C was this hypotenuse, and it was always the longest of the sides of the triangle. But in oblique triangle, the C may be longest, or it may be the shortest, or it may be the middle side there. So the name does not tell anything about the side of the that side, the size of that side. And again, these angles are named with the help of this opposite side. So A is the angle which is watching the alpha is the angle which is watching A, and then beta is the side which is watching B, and C or gamma is the side which is watching C, which is opposite side. Or then you may use these capital letters A, B, and C also in the place of angle. This gamma, I've learned to write it like that, but actually from this my formula book there is kreikkalaiset aakkoset or Greek alphabet. Greek is kreikkalaiset and aakkoset is alphabet. So here is this gamma, and it is actually written like that. But not to have any misunderstandings, because this letter actually seems like letter Y, Y in Finnish, Y. So that's why I usually try to write it a little bit differently, that you don't mix it to the letter Y. This is probably not exactly written, but if you see myself drawing this kind of letter, then you maybe understand it is gamma. So let's take an example where we have side A equals, I will take simple numbers here, side A equals 2 and side C equals for example 7, and angle beta equals, for example, 32 degrees. So these are my starting values of the problem, and now I have to find out the other parts of the triangle. So that means I don't know the length of side B, that is unknown, and I don't know the angles alpha and gamma. Those are unknown for me. And in this example, I also want to calculate the area of this triangle. So let's put that also unknown. In Finland, we usually use A, big A or capital A for the place of area, mostly in formula books. This is most common. Where do I found some? For example, here we have simple figures in geometry. For example, this square here, neliö in Finnish. So there is this big capital A or big A there. But I know that in some cultures or mathematical cultures, they use the capital S letter for the area. So I'm not quite sure. You may write to the chat box. I will open so that I will see. Yes, I now notice that you had very friendly asked how I am today. Thank you for your concern. Mitä kuuluu tänään? That means how are you today? Yes, that was correct Finnish there. So please feel free to write if you, for example, in your culture or your homeland, you use another letters for this area. So just write there. So this oblique triangle, it means that it is whatever triangle, but usually we use the formulas we get soon here. They are such kind of triangles that are not right angle, so there are no 90 degrees angle in this triangle. That means oblique triangle. Vinokulmainen kolmio in Finnish. And now we have this situation. We know two sides, and we know one angle of the triangle, and I will take the formula page, which in the Moodle I will show in the camera. I have this part here, study material for trigonometry, and there is lesson notes from the earliest teachers of these courses, and then there are some memory rules for the right angle triangles. I'm not really sure if I had this earlier already, but this trigonometry in oblique triangles, there are some formulas we may use when we are having that kind of triangle. So there is this triangle which is drawn a little bit differently as in my example, but the same notation logic there holds. So A and alpha are opposite each other, and B and beta and C and gamma. Here you see that when I have used the formula editor of Word, so it gives this kind of letter in place of gamma. So actually it seems like it is almost same as capital Y, and I actually don't like that, but of course in the situation on this case we are having right now, we can understand that this means gamma. So there are the rules we use in oblique triangle or in any triangle. Law of sines, or you may also call sine rule. In Finnish it is sinilause or theorem of sine or sine theorem. And if we watch this, actually it means the same as it is written there in Word, law sign in words. Wider. In every triangle, the ratio of the length of the side to the sine of the opposite angle is constant. That means that if we have for example, side A here, and we divide it by sine of alpha. So A divided by sine alpha, it is always the same as B divided by sine B beta, or C side C divided by sine gamma. So there is always the I don't know why does it not show it well here. There is always the same letter in top part and bottom part of this division. A divided by sine alpha, B divided by sine beta, or C divided by sine gamma. Or if you use those capital letters, so you will have capital A here, capital B here, and capital C here. And this is always the constant. So division gets the same result. This is the sine rule, and this holds also for the right angle triangle. In right angle triangle or right triangle, the gamma is always 90 degrees. Oh, now I remember I forgotten to accept one wanted to join. Oh, I'm so sorry. There. I hope he is or she is probably possible to get to this meeting. I unfortunately I forgot to accept his or her. Yeah, wanted to join the teams. In right angle triangle, this angle gamma is always 90 degrees, and if you calculate what is sine of 90 degrees, let's take a calculator. In my calculator, sine 90, that is exactly 1. So that means that in this sine rule, if you use this for right angle triangle, this sine gamma is same as 1. So actually this C divided by sine gamma is C divided by 1. So that is simply C. So this here is C. And now if this is C, we get the definition of the sine in right angle triangle. So for example, A divided by sine alpha equals C. And we may change the places of C and the sine alpha. If we change the places there, so the C will go there and sine alpha will come here. So we can read sine alpha equals A divided by C. And that is exactly the rule for the right angle triangle. And the same holds here. If we have here C and we change the place with the sine B beta, we get sine beta here, and it equals B divided by C. And this is again the definition of sine beta in right angle triangle. But actually it is no use to use these sine rule formulas for right angle triangle, because they are more easier one to solve with those easier equations we had earlier. And then we have the sine rule or law of sines, and then we have cosine rule or law of cosines. In Finnish, I will write this in paper soon, but in Finnish we say this, or we call this kosiinilause, cosine theorem in English. And now if we watch these, there are 3 formulas here, and the logic here, it is maybe easiest to start with this last one here. So actually here, when we have c squared in the left part of this equation, c squared. And we forget this part which I painted right now, and watch only the beginning of this equation. That is exactly the Pythagorean theorem in right angle triangle. And if we watch this ending of this equation, there is cosine gamma. And what is cosine gamma? If we have right angle triangle, this gamma is 90 degrees. And if I again take my calculator and check what is cosine 90 degrees, sorry, 90, it is 0. So in the cosine of 90 degrees angle is 0, and if I watch this cosine rule here, and if this is actually 90 degrees, this gamma angle there, so this cosine gamma is 0. So this part of here becomes 0 because you are multiplying by 0. And that means that when you have a right angle triangle, this part is eliminated from the equation, and that leaves you this Pythagorean theorem, which you use in right angle triangle. But then we have these two parts there also, and everyone has the same logic that if we start with one letter in left hand side, so for example here we have a squared, then we have to have the other sides in the other side of the equation, and there we have the other letter. So if I have a here or a squared here in the left hand side, then in the right hand side I have to have b squared and c squared. So there are these other two letters, a, b, c. And for example, in this formula I have b squared in the left hand side, so in the right hand side I have a squared and c squared. So there are always these three letters there. And here, as we already watched this or looked at this last one, there is c squared and there are a squared and b squared in the right hand side. So there is the same logic in all formulas here. And then there is this part here. There is always the same logic. There is -2 multiplied by the other two sides. So if I start here with A, I have B and C here. A, and here is 2 times BC. And if I have B here, so I have 2 times AC. So here are these other two letters. And here I have C, and here I have AB. So actually, when you watch the right-hand side of these formulas, you always have only these two letters there, BC, BC. Here, AC, AC, AB, AB. And then because this is cosine rule, we have cosine here. And the easy way to remember to write the cosine rule is to remember that it starts and ends with the same letter, so that the angle is written in Greek form. So here we have A, and in the end we have alpha. Or if we use that capital letter, there is capital A. So it is the same letter, A and capital A or alpha. Here the same, B, so here is capital B or beta in Greek form. And here C and capital C or gamma in the right hand side. Yeah, so those are the rules we will use. Let's not go to the area yet, but let's start to continue with this example. And now I know A, C, and beta, and let's see if we can get something done with the help of these formulas. They are easy to remember, but if you are not used to them or they are new ones, it takes a little bit when you start learning how to use them. Actually, here to use sine formula or law of sines, there we have to know at least one angle, and we know now this one angle. But then we should also know the opposite of this angle. For example, if I know beta, I should know also B letter or B side of that triangle, because here it is in this form. And right now I don't know that. I don't know B. It is unknown. So in this point I can't use the sine formula or this sine law of sines. So I have to go through them and or pass them and go to law of cosines. And let's move this paper so I can see the law of cosines there. I know AC and beta, so if I have to turn to cosine rule, so I have to find that where there is beta, so that means this middle one here. Sorry. Sorry, I didn't hear what was the question, or was there? No. Unfortunately, I can't hear from my headphones. I still don't understand what is the problem in these headphones, because I can't hear. I have to take them away, and you know. Well, maybe you may use the chat box if there was something I may answer later. So I have to use this formula here. And when I watch that, actually I know everything in the right hand side. I know AC, and beta. So with this formula I can calculate the value of B squared, and equals the right hand side. I can calculate the right hand side, and with the help of that I can find out what is the B. So let's take that. And as I said, this cosine rule or law of cosines, in Finnish it is kosiinilause. This is one word. Kosiinilause, cosine theorem. And the one we are using now, I don't actually, you can see from camera that I am watching the theorem there, or the page I showed you just, but I will try to write that without watching there. So I want to calculate B, so I get B squared, and after that I have choose this form of this one of these three formulas, B squared. So I will put A squared plus C squared in the right hand side, and then I have this minus part there, minus 2 times, and always the same letters as here, AC. So first these squared parts here, and then the same sides of the triangle after this minus 2. And then this was cosine rule, and because there is B, here it must be beta. So this is how it is written. And right now I know A, C, and beta. This is a way when you are not so very used to these formulas, it is many times useful to first write all the formulas in the paper, and then somehow, for example, with a color pen, put some marks there to show that those parts of the triangle you already know, and in this case I know these parts. And then if I find a formula where there is only one unknown, I can solve that unknown from that formula. So right now I may put those numbers in the place of those letters. So A is 2 squared plus 7 squared minus 2 times 7 times cosine 32 degrees. So I will get, actually it depends on the calculator you are having. These modern calculators gives you possibility to actually solve the problem in one pressing of the enter. But in most old-fashioned or simpler calculators, you mostly have to first calculate the value of this and write it, for example, in this place, and then use your calculator when you have found out that intermediate result. But I will calculate it in this calculator. Oh, sorry. So I get this kind of value there. Let's write it there to the paper. This is one problem many times students when they are calculating. When you have to get the result in some precision. For example, it is told in the problem that you need to get, for example, values of lengths of sides of the triangle into accuracy or precision, which is, for example, 3 decimals. That means that you should not round this intermediate result too much. Many times it is wise to write the whole number to the paper. Well, actually not the whole number, but I will write with this precision. I will write these 3 dots there, so that means that I actually will use the accurate result which I got from my calculator. So right now I know that b squared equals this number, and to get the value of b I have to take square root. So b equals square root of this number. I will put 3 dots there. And in this calculator, it is possible to pick the value I got there. So I would do so that I get the square root there. There is square root in this calculator there. And if I want to get the answer which I got there, I could pick that from there. So I don't have to write that there. But in many calculators it is possible to do so that when I have this value there, I only have to press the square root button. For example, this is older calculator. I will write the value there, so I get, sorry, this is bigger. This shows bigger figures there. I like more this old-fashioned there, so I will write the number there. I haven't used this so much. This is my old calculator, but it is so long I have used it. For example, there is not space for more figures in this my newer calculator. There are more decimal places, and now most usual was that you got this answer and then you just press the square root button. But you also may do so that this square root, this is the same as to raise the number to the power of half or to the power of 0.5. For example, if I have 25 and I want to get a square root of that, which is actually 5, I could use the square root there, but I also could raise that to the power of 0.5. I took that exponent button or power button there, and now I want to get the result, so I get the 5. The square root of 5 is 5. For example, in this calculator, I many times do so that when I get this result, I now understand that I have to take a square root of that number. I most usually use this button there, which is exponent button. It is this kind of accent mark there. Is it accent? I don't know what is. So I will put this but push that button, so it tells me that I am taking answer of the earlier result, and then I will put 0.5 there, and this will give the square root. If you remember, I had got this same result with this older one earlier before I calculated that. Yeah, another example. So this is the value of b. And if we need to round that, for example, to 2 decimal places, it would be 5.41. This is just an example. It is not said in this problem what would be the accuracy of the result. But for example, if it is asked to round the numbers to 2 decimal places, then it would be like that. Actually, I got this result. I will do so that I will check by drawing this, because it is not used to continue. For example, if I need to use this number or this value of b in further calculations, if I had made best error or mistake when calculating this b, so that error will or mistake will go on, and it will make mistakes to other answers to this problem also. So I will right now try somehow check the value of this by drawing a picture of this triangle. So I draw a picture with the help of my is this a protractor, or I don't know. In Finnish we call this astelevy. Astelevy, so it means this kind of where we have angles there. Do you remember? Is it protractor in English? I'm not quite sure. Yes. Okay, that is. Let's take that question mark there. So I am now 100 sure that this is protractor. Aste means degree, and this levy means it is some kind of plate. So this is some kind of plate with degrees. And if I try to draw a accurate picture of this triangle, I have the C. I will take the C first. I will draw it here 7 units, 7 centimeters. This is C 7, and then we may choose that beta is the angle which is written or drawn in this place. So I will take the 32 degrees. It is somewhere here. So this side will go somewhere here. So this is beta 32 degrees. So this means that if this is beta, so the side B should be somewhere here. We don't know the exact place right now. So the C is there and B is here, so this must be A. And A is 2 units. So I will draw the A here with the length of 2. So it will be only here. It is a little bit too small. Here will be A. 2. So the last side of the triangle would be there. This is so small. I'm sorry. I should have drawn a little bit bigger figure, but it goes like here. So this is the B side of that triangle. And now if I check from the picture in my accuracy of drawing, I would get somehow something like maybe 5.4 or 5.3. Well, 5.4 is quite near. If I check that, maybe that is quite near 5.4. Many times these simple drawings are useful to check these problems, because by using pictures you many times can be quite check those or if your calculators are correct. For example, if you would have got 15 for the value of B, and this picture shows that it is not even near of 15, it is much smaller, because this is 7 and this is smaller, shorter than 7 units. So you could be quite sure that you have made some mistake. Most common error in these kind of calculators is that you forget to use the square root. For example, you would get 29 to the result, and it is easy to see from this picture that it must not be, it cannot be correct one. So now we know all the sides of the triangle. We know A and B and C, and we know one angle there. We could use now again. We could use law of sines to calculate the angle there. So because we know now, we know B, we calculated it and got that number which was almost 5.4, and we know that beta is 32, and we know A and we know C, so we may calculate alpha and gamma from the sine rule. Let's begin with the alpha. So we get here this part, and we know this part. So this is the formula we will be using. Note that this law of sines also contains 3 formulas. 2 of those are easy to see here, because here is the one and here is the another one. But also the third one you get when you are taking the first part and put it equal than as the the part in the most right in this formula. So this is the third one. But right now we are using this here, and we are using sine rule, which in Finnish is sinilause. Oh, sorry, you didn't see what I was writing. Sine rule, sinilause, sine theorem, and it is written as I saw earlier: a divided by sine alpha equals b divided by sine beta. And right now we know a, and we know b, and we know beta, and we want to find out what is alpha. The sine rule is always in this form. It is this kind of fraction format. There is fractions in both sides, or divisions in both sides of equations, and we will solve this by using cross multiplication. So this means that we will multiply this equation with cross multiplication. So that means that we will multiply these parts of the a multiplied by sine beta and b multiplied by sine alpha, and it is useful to write the equation so that this unknown goes to the left hand side. So the unknown is there, so I will write this first. So it becomes b multiplied by sine alpha equals a multiplied by sine beta. In some formula books, this sine rule is written in this format. But for me it is not so easy to remember this in this way. But maybe it is quite easy to remember that if you watch this formula here, so it starts and ends with the same letter. Here is B, and here is beta. And in the middle one, there in the middle of the equation, there are also the same letters, A and Greek A, that means alpha. So maybe it's quite easy to remember that you will write B and then in the end beta, and here you will write alpha, and after the equal sign A. And after that I want to find out what is alpha, so I need to divide by b. So I get sine alpha equals a times sine beta divided by b. And now we know now could calculate the sine alpha, but I can also calculate it in one step. So I will solve alpha by using inverse sine, same as in right angle triangle, sine minus or inverse sine, and I will take that from the division shown above. So now I will put the numbers there. I suggest it is useful to solve this formula, also this equation first, using only these letters, and put those number values in the end, because this you don't need to write this kind of numbers there, because it gets a more nasty ones of these steps. So now I will write the number values there. So A value was of 2, and then sine beta sine 32 degrees, and then B was calculated there, and I will write more exact value, not this rounded value, but this more exact value here. And then I would calculate what will the result be. In this calculator, I could write it in exact this way as it is in this paper, but because I know that in many calculator or most calculator you have to first calculate this, so I will draw this also in the same way. For example, in this calculator, this is only possible to first calculate what is the value of this division there. So I will use this more old calculator. Then I divide by 5.40875. I will take more decimals from the other calculator. There are 7009. I think that is enough. And then I get the result. So this is not yet the angle, but this is sine of that angle. And then I have this again. I draw these 3 dots. That means that I will use more accurate results. I only write in the paper only the beginning of the word of the figure of the value of the sine. And then I want to find out what is the alpha. I will use this inverse sine, which is in this calculator shown in the top of this button here. So I will use the second or inverse button there. So this is the way to find out the value of the angle. In this other calculator I will show I could use it was wrong. Inverse sine I will use. I can write in this calculator. It is exactly in the same form as it is written in the paper. And I get the same result, or almost the same result, because this left with this left calculator I did not have exact the same number, but it is reasonably close to each other. So this will be 11.30014, etc. degrees. Many times problem or error or mistake in these calculations is that you forget to take this inverse sine. You only calculate this value and forget that this is not the result yet. You have to use this inverse sine still. So we got 11.3 degrees angle, and let's check that again from this picture. The alpha angle is here. Here is side A. So in the opposite part of the triangle, there is alpha. it is very small angle, and if I try to calculate the value of it, it takes a little bit problems. But let's take another ruler there. If I found it, there is some. Let's take that. If I put the 0 in the angle of that and put this ruler there, it is about, hard to see from the camera, but I can see it better. It is quite near 11 degrees. Maybe this camera vision doesn't show it correctly, but I don't lie when I say that it shows that 11 degrees is the answer, and as you see, we almost got the same by calculating, or I should say that that drawing gave almost the same as we calculated. So we may be quite sure that we made this correctly. And if we round it to the 2 decimal places, as I said, it was not said in the problem what would be the accuracy of the result be, but if we use the 2 decimal places accuracy, so this would be 11.30 degrees. This 0 is important. If you need to get the answer in the precision of 2 decimals, you have to also draw this 0 there. Now we know all parts of the triangle, but we don't know the gamma angle yet. Of course, we could use the easy way to solve the last angle, because we know beta and we know alpha, and because all the angles of the triangle every time sum to 180 degrees in every triangle. In the right angle triangle, there always was the angle of 90 degrees, and the other angles, alpha and beta, they share the 90 degrees that was left. But in that triangle, also the sum of the angles is 180 degrees. So here also we could use that. So we could sum these and subtract the answer from the 180 degrees. But I have one reason, because I want to calculate this angle also with the help of sine rule, and you will see the reason soon. So again, I will write here, how about angle gamma. Let's use sine rule. And as earlier we had this method, there is side divided by angle, opposite side of that side. And now we want to find out gamma, so we have to use C and gamma in the sine rule. And we now know A and we know alpha. We calculated the alpha there. So let's use A and alpha, C and gamma in that sine rule. So A divided by sine alpha is equal than C divided by sine gamma. And we want to solve gamma from that equation. So cross multiplication again, gamma is the unknown, so I will put the cross multiplication sign here. So I will multiply first these two here. So I will get the gamma to the left hand side. So I get A multiplied by sine gamma equals C multiplied by sine alpha. And then I need to find out what is the value of gamma, so I will divide by A. So I get, by the way, here again you see the same logic there. It starts with A and ends with alpha, and in the middle there is C and gamma. So there is the same logic. So I get sine gamma equals C times sine alpha divided by A. So the gamma I get from inverse sine of this expression. And let's draw or write the values there. C was given in the problem, it is 7, and A is also given in the problem, it is 2. This alpha we calculated there, and we got this, so I will put the more exact value, because this rounding, if I use this rounding value, it gives me rounding errors there. So I will use the more exact value. And let's see what my calculator gives. Sorry, there's some problem there. Inverse sine. Actually, I took the different. I have almost the same calculators here. I seem to use both today. Yeah, actually, I use this one. Let's take this one, because I have this correct value of alpha there, so I can pick that there. Let's take that. Inverse sine division 7 times sine, and then this value. I will, in this calculator, I can copy that value there, so I can hit Control C, the same as in computers, you may copy Control C, and then I go to place where I want to paste that, and Control V, the same as in computers, Control V, that copied that there. And in the bottom line, below the line, there is 2. And from this we get value 43 degrees. But what is the problem? If I watch this picture here and we got the result 43 degrees, and it is the angle gamma, and this should be in the opposite side of the triangle. C is here, so the gamma angle is this angle here. And if you watch clearly, and you don't need to be so very clear, you immediately see that this angle, it's much more than 43 degrees. If I take this protractor there, I will see that this is about 140 degrees about. this angle here. Actually, this angle which we got from calculator is this angle here. If I take again here and put it there, so you can see that here is 40 degrees here, and this is some degrees over that degree. It is about 43 degrees in this picture, and this is the problem when using sine rule when you are calculating angles. You actually can't never be sure if the result is okay. But many times it is helpful to draw a picture that is somehow in scale. For example, in this point, we draw this picture which is quite near the scale. And let's write this memory rule. But from the picture we see that this is not this is not correct value for angle gamma. The right value seems to be about 140 in Finnish 140 degrees. So I will take a red or almost red. When you use sine rule to calculate value of angles, be careful. That doesn't mean that we can't use it, but you have to be careful, because the right value of angle is either the value you get from calculator or the value you get when you subtract the value from calculator from the 180 degrees. Either the value you get from the calculator or the value you get when subtracting the value from calculator from 180 degrees. So in this case, in this problem, we have two possibilities. In this case, gamma is either this value here or gamma is 180 degrees minus this value. So in this case it is the, where is my right I actually have here 3 calculators, and so here is the value I got from my calculator. If I subtract that from 180 degrees, I get this kind of value there. And now from the picture we can see that the correct one is not 43 degrees but 136 degrees there. I have to measure that again. Did I actually get that kind of result? Let's check if that is. Maybe the paper is useful there, easier to see. This was why did I draw such a small picture? But here I would see that it is about, here it is 130 degrees, and it's maybe 5 degrees more. So in this picture it seems to be 135 degrees about. So we may be quite sure that this is correct one. So from the picture we see that now the gamma is this last one. And again, if we round that to, was it 2 decimal places, it would be this kind of number. Last one, which in this example is asked, is the area of the triangle. And in this case, I would suggest to use this sine formula of angle, of area. I will try to show you that from my material. Here, this is sine formulas for the area of the triangle. This is quite easy to remember. There is some notation there that there always exists every 3 letters A, B, C, but one of the, sorry, can't be seen correctly, but one of them is written in the Greek form. So I hate this. As you see here, we have this A and B in this formula, and the last letter would be C. And here, because this is sine formula for the area, C, in the place of C we write gamma, or this capital C. If we use A and C, then we need to get B, so it is beta, or capital B. And here we have B and C, that leaves us only R, A there, so there will be alpha. Or maybe it's more easy to remember this with this. Let's take the, now remember there, for example, A, B and gamma there. So when I take the picture of the triangle here. Where is A and where is B and where is gamma? A is here. This is the side of A. Here is B. And between them there is gamma. The same holds, for example, A and C. If we use A and C, between them there is angle beta. A, B, C. And here we have B and C, and between them there is alpha. So there is all again A, B, C. So it is quite easy to remember the area formula, so that when we calculate the area of the triangle, we every time get half times, then we take, where is my, take, I don't remember what I said earlier, but for example, if I take, use this angle which is told in the problem, if I take this beta, then I need A and C. So they are told already in the problem. So I can get this by multiplying A times C times sinus beta. So this half or dividing by 2, it is in every triangle area formulas, because the most usual formula for the angle of triangle is base times the height, base multiplied by the height of the triangle divided by 2. So there, this again, this dividing by 2 in this form, half times this multiplication here. So in this case we have 1/2 multiplied by 2 multiplied by 7 multiplied by sinus 32 degrees. So there are these starting values in this problem. I will write in this calculator in the same way as in paper, and it gets me the answer. If in this problem we didn't use any units, so they were, the sides of the angle were simple numbers there. But for example, if these were meters, 2 meters and 7 meters, so this would be square meters, the unit of the area. But in this case we didn't have any units. This is also somehow possible to check from the picture, because I draw the C side here, it is 7. And if I measure from this picture the height of the triangle, I mean this length there, well, this is so small of a triangle, but in this picture it seems to be about 1 unit. This the height of this triangle. So if I multiply 7 with this height of the triangle, which was 1, 7 times 1 equals 7, and when I divide it by 2, I get 3.5. So from this picture I would estimate that the area of this triangle is about 3.5, and this is quite near to that value. Again, I have to say that I draw too small of a picture. I should have drawn this at least twice of this side, so it would be much easier to check those answers from the picture. But this is reasonable enough to be quite sure that this is correct answer. By the way, some words in Finnish concerning this area, m squared or square meter. In Finnish it is neliömetri. Neliö is this figure, as maybe we had this earlier. This is neliö, and metri is the same as meter. Here again we see that word neliö, this figure here. So it is neliömetri in Finnish. If you are calculating volumes, then you have cubic meter in English, and in Finnish it is kuutiometri. This cubic, it comes from this. This is called cube. And in Finnish it is kuutio. So this means the same as in English actually. These words there, this neliö, you can understand if you remember what is the number of 4 in Finnish. It is neljä. It means that there are 4 sides in that figure, and that's why it is called neliö. And in this kuutio you have 6 of those sides there. For example, if you throw dice, you have 6 possibilities to get 1 or 2 or 3 or 5 or 4 or 5 or 6. So there are 6 sides of that cube. So 6 is in Finnish it is kuusi. So that is the reason where this kuutio comes from, this kuusi word, 6 word. What would there also be said? Some other words also. Square meters, cubic meter. Well, volume. That is in Finnish tilavuus. For example, if you want to calculate the volume of this cube, in that meaning, this volume, it is tilavuus. These cubic meters are the units of volume or tilavuus. Unit, it is yksikkö. And if you remember the Finnish word for number 1, this is yksi. Yksikkö. Yes. I will give you some exercises to count. These are not assignments yet, but to practice these oblique triangles, I will give you some problems, and feel free to ask any help if you during weekend you have problems in any mathematics or in any kind of things, you may send me email or WhatsApp messages, or it is always possible. I try to answer to those questions as soon as possible. But I will give you some problems to solve. Solve all sides and all angles and the area of the triangle. So this means that I give you some starting values from the problem from the triangle, and then you have to solve unknown parts. So if you don't know all the sides, you have to calculate those all sides, and so same holds with angles, and then also the area. I will put the right answers to the Moodle probably tomorrow, so you can check your calculations, and if you don't get the right answer, then ask help. So in the first problem, you know B and C, and you know the angle alpha. Second one is, I give 4 problems for you. In the second problem, you know all the sides of the triangle, so those are known, but you don't know any angles. I was ill and we missed some lessons, so in this point of studies, I actually am a little bit longer in teaching with the campus group of this course. So if you find some problems hard to understand, or I haven't had time to go through every examples, every kind of variation of these problems, you may find the help from the videos from the campus course or campus group of this course from yesterday's and today's lessons. Today's lessons are not right now there in the Moodle. I will put them after these lessons, and you will find them there. But I think some of these problems you are possible to solve with the knowledge from today's lesson from your group. So today there will be no more. We only have this 2 hours, and we didn't have any break. So I think we may end now, and you may practice these problems during weekend, and of course today also, if you have time to solve these, and you may send me your answers, and I will check them. As I said, these are not yet any assignments. Actually, you don't get any points from these, but this is only to practice these problems. I will try to get you 1 assignments ready. Probably during weekend it will come there to the Moodle. And remember, you should ask a number for your to get your own problem, because I will give those assignments in the Excel format, and it is such kind of Excel that in some row you will find your own own assignments. There are different values, starting values for the problem. So you need to a personal number to start doing those assignments. But as I said, those are not ready yet, and I will try to give you first assignments during this weekend. But I thank you for today's lesson, and I will end the recording soon, and I wish you hyvää viikonloppua. Hyvää viikonloppua. Happy weekend or good weekend. Loppua. And please stay in contact during weekend also if you have anything to ask. I will be very glad to have possibility to help if anyone needs help. But this is everything for today. Thank you. Bye bye.